is our last video for Module 3, polynomials. We're going to look at solving quadratics. So I've got a few different examples. We're going to look at solving using the zero product property, and then solving using the square root property, and then finally solving using the quadratic formula. The zero product property states that if a times b equals 0, then either a equals b or 0 or b equals 0. So basically, if you're multiplying two things together and they equal 0, one of those two things must be 0. So we're going to use that to help us out here. If you have a quadratic equal to a 0, we can, if it's factorable, we can factor it and then use this property. So I'll go ahead and show you how that works. Now, remembering from factoring quadratics that you're looking to see in this case, well, multiplies to be 30 and adds up to be negative 11. They must both be negative because they are multiplying to be positive but adding up to be a negative. And that would be 6 and 5, a negative 6 and a negative 5. So you've got x minus 6 and x minus 5. So now what we've done, we've got this, now this is an equation. When we factor, you're just factoring. You're just writing them as, writing an expression in terms of its factors. But when we're solving, we actually want to figure out what that value is. When you're solving a linear equation, you can isolate x, but we can't isolate that x very easily here. If we try to do that, we've got an x squared term and an x term. So that's why I'm factoring this. So once I get here, now I have just an x. I see an x, and I know how to deal with that. So, but we're going to use that zero product property. If you have the product, which means multiply, two things, they equal 0, then one of those two things must equal 0. So in this case, either x minus 6 equals 0, or x minus 5 equals 0. And then we solve. If you solve this, to solve for x, we're just going to add 6 to both sides, and we'll get x equals 6, or in this case, add 5 to both sides to solve, and we get x equals 5. So we get two answers there. X could be 6 or x could be 5, and you could go back and plug that in and very easily see that it would work. And that's the nice thing about equations, is you can always check your work by plugging it back in. All right, here's another example. This one's not quite as easy because we have this 2 out here, but notice that all of these terms are even, so we can actually factor out that 2 before we do anything else. So factor that out. And then I'm going to do the same thing that I did here. I'm going to have to squeeze this in. I don't have as much room as I did for the other one. I'm going to factor this out. Notice these are both positive. So it's going to be 2 times, those are going to be x's. And then what multiplies to be 10 and adds up to be 7. That'll be 5 and 2. And then, so I have the product of 3 things that equal 0. Again, I'm trying to figure out what x is in this case. I know that 2 is not equal to 0. So when we're factoring, we can't get rid of that 2, but when you're solving, we're trying to figure out what x is, and that 2 doesn't help us. 2, we know that 2 is not equal to 0 when we're using the zero product property. So we can ignore that. And we just want to know this part. So either x plus 5 equals 0 or x plus 2 equals 0. And then I can solve. And this one I'm going to shortcut a little bit to save space, but I can subtract 5 and I will get negative 5. And on this one, I can subtract 2 from both sides and get negative 2. So my answer is x is equal to negative 5 or x is equal to negative 2. And that is the solution. All right, I'm realizing I kind of squeezed that in a little bit tighter than I wanted to, but hopefully you can see that. And in this, we're going to move to a real-world example. So you have a garden measuring 12 meters by 16 meters. It's to have a pathway around it, increasing the area to 396 square meters. What would the width of the pathway be? So we know the original dimensions of the garden. We don't know how big the pathway is, but we know what the final area is supposed to be. I would always draw a picture with a problem like this. So we have a garden. It's 12 by 16. We want to have a pathway around that garden, and it's uniform. It's understood to be uniform around. We don't know what that is, so we'll call it x. Anytime you don't know what it is, call it x. We also don't know what that dimension is. We'll call it x. We don't know what that is, we'll call it x. We don't know what that is, x. So the distance of these pathways, we don't know that, but they are going to be the same. The pathway is going to be the same distance all the way around. So if you recall area, we do area equals length times width. And in this case, I don't know the length and the width. I know the length and the width of the original garden, but not with that added pathway, and I don't know the dimensions for that pathway. But I do see that I have x, 12, and x. That makes that length or width, depending on how you look at it, and x, 16, and x makes that width. So like the unknown, you have that on both ends, and then that's 16. So x plus 16 plus x, and 12 plus x plus x. So the dimensions here, this is actually going to be 12 plus 2x, and this is going to be 16 plus 2x. Drawing a picture helps see that a lot easier than just trying to do this without that illustration. So now I have the length times the width, and I know that the area from the problem, this is my area, so that's going to go in right there. So I have an equation that I can solve. So I'm going to plug in 396 equals length times width, which is 16 plus 2x and 12 plus 2x. All right, and then I'm going to multiply this out. Now notice I'm going to end up using the zero product property, but up here it was already set equal to 0. This is not. So when you have a quadratic and it's not set equal to 0, if you want to use the quadratic formula, which we're going to get to, or the zero product property, we have to have 0 on that one side. So we're going to try to get 0 over here. But in order to do that, I'm going to multiply this out first because I need that to be simplified before I'm going to be able to bring that over here too. It'll make it easier, so I'm going to bring that here. And then 16 times 12, I'm going to multiply that and we get 192. And then 16 times the 2x is going to be 32x. 2x times 12 is 24x. And then 2x times 2x is 4x squared. All right, so I've got that, and now I don't have 0 on this side, but I can easily do that by subtracting the 396 from both sides. Save some space. I'm not going to show that here, but what I'm doing is I'm subtracting that on both sides. That'll leave me a 0 on this side. And if I take 192, actually I'll go ahead and write this out. 192 plus 32x plus 24x plus 4x squared. And then I'm subtracting that 396. So you can see that I'm doing that there. And then I'm going to combine these like terms. So I'm going to have 0 equals, and I'm combining the 192 minus 396 is negative 204. And then these terms, 32x and 24x, will give me 56x. And then I have this plus 4x squared. All right, so now I have it equal to 0. This is not super easy to factor, just looking at it right here like these were, or at least this one. But it is kind of similar to this in that I have a common factor. 4 does divide evenly into each one of those. I'm also, again, to save space, I'm going to change this and just write it in this order because we're used to seeing it like this. To save some space, so I don't have to write that again. But what I'm going to do is I'm going to factor out a 0. I'm going to factor out a 4 because that is a common factor. So I'm going to factor out a 4, and that's going to leave me with x squared plus 14x, and then minus 51. And then I'm going to factor this. This is a little bit harder to think of, like what multiplies to be negative 51 and adds up to be 14. We are going to learn the quadratic formula, which if you can't figure this out, the quadratic formula will work. But in this case, again, we're looking to see what multiplies to be x squared, which would be x and x. And then multiplies to be negative 51 adds up to be a positive 14. It'll be plus 17 and minus 3. 17 times negative 3 is negative 51. 17 plus negative 3 is 14. All right, so this is kind of similar to this step right here where we have 0 on one side, so we're ready to use that zero product property, which states that we can set each of the products or each of the factors equal to 0 and solve. Again, 4 can't be 0, so we don't need to worry about that. So it's either x plus 17 equals 0 or x minus 3 equals 0. And if you solve, this is going to be x equals negative 17 or x equals 3. I get 2 answers, so I'm like, okay, well, what do I do for the word problem? But the nice thing about word problems is there's context, so you can use that context to help you figure out the solution to the problem. Distance cannot be negative, so this cannot work. We got that as an answer, but it's extraneous, it does not work for the problem. That means that our answer must be the 3. And then you can check your work. If we take 3 plus 12 plus 3, you're going to get 18, and then 16 plus 2 times 3 will be 22, so 18 times 22 does indeed equal that 396, so you can check your work for the context of that problem. So that is an involved problem. It's a good problem to show you kind of where this stuff is relevant in the real world. You might not have a garden that you need to put a path around, but there might be a city planner who needs to do that. And there are definitely real real world examples in business and across the board that would use this kind of scenario. All right, so I'm going to show you the square root property. Now, the square root property is unlike the other two methods for solving. You don't have to get 0 on one side. So the square root property basically just says if you have only the x squared term or only the squared term, whatever that is, if it's a or y or whatever it is, if that's all you have, you don't have just an x term, then we can isolate this. And then to solve, you kind of, like solving linear equations, you take the inverse operation. So if you have addition, then you subtract from both sides. If you had multiplication, then you divide on both sides to get rid of that. Well, in this case, what undoes squaring something would be taking the square root of that. So we're going to take the square root of both sides. Here's the trick with this, and you notice this with the other problems that we were doing with the zero product property. You get two solutions. There are two different numbers that you could square to get 4. And you might be able to look at this and tell what the answer is, but this property will work with all of these. So you're actually going to get two solutions. It could be plus or negative 2. So plus or negative 2. We can write it like that. That indicates that it could be 2 or negative 2. You could also write it like x equals 2 or negative 2. But both of those would work. 2 squared is 4, and negative 2 squared is also 4. Here's another example. All right, this one, I don't completely have this isolated, but notice there is no x term. Again, square root property works when there's just that x squared term, but no x term, or y, whatever the variable is. But in this case, we need to isolate that. We do have multiplication here, so I'm going to undo that operation first by dividing. Opposite of multiplication is division. So those will cancel, and I'll get x squared equals 9. And now I'm going to vote the same type of vote that I was in over here, where I'm going to take the square root of both sides because that will undo that squaring. And the square root of x squared is just x. Again, that undoes the operation. And then the square root of 9, again, plus or minus 3. I know, if I were to ask you what the square root of 25 is, generally we say 5. Well, that's right. That's called the principal square root. That's generally what we think of. But technically, because we are solving an equation, both of these values would work to solve as a solution to that equation. So we need to write both of them. If you don't, technically you're only halfway right. So you do want to write both. All right, one more example of these. All right, now this one is a little bit different. Here we needed to get rid of that 3, and here we have a 1, but we can't get rid of that 1 because that's part of what's being squared. So it's basically, you have what you're squaring isolated already. It's the x plus 1 that you're squaring. So we're ready to go ahead and take the square root here. So we're going to take the square root of both sides because that's what we're trying to undo in that first step, is undo that square. So that's going to give me x plus 1, square root of a square, cancels out. And then this is going to be plus or minus 3, just like we got up here. But we're not done because that x isn't isolated. So this is one where we need to then continue this, and it's actually, we're going to subtract that 1 on both sides, just like a linear equation. It's just this plus or minus 1. We have that or plus or minus in front of that 3 that we need to consider. So this would be negative 1 plus or minus 3. So this means it could be negative 1 plus 3 or negative 1 minus 3. So we're going to consider both of those possibilities. So this would be 2 or negative 4. And if you go back and plug these in very quickly, 2 plus 1 is 3, squared is 9. If you take negative 4 plus 1 is a negative 3. Negative 3 squared, which would be negative 3 times negative 3, is a positive 9. So both of those work in this situation. So there's some examples of the square root property. All right, the last thing we're going to look at in this unit is the quadratic formula. Okay, so we saw factoring and using the zero product property to solve. That has its limitations. If it was a decimal value, that would be difficult to come up with factoring, nearly impossible. And with the square root property, we saw that that has its limitations. It has to have just that x squared term. The quadratic formula is the one that is no fail. It's a little bit more involved as far as the process, like factoring. If you can factor, you're going to want to factor and use the zero product property because that's the easiest. Square root property is pretty straightforward as well. So this one's a little bit more involved, but it always works. It's no fail. So this is the quadratic formula. If you're trying to solve for x, we will take negative b plus or minus b squared minus 4ac all divided by 2a. And the a, b, and c, this is referring to the coefficients in the polynomial. So your a is the coefficient of x squared, b is the coefficient of x, and c is your constant term. And that's what you'd be plugging in. So here's an example. If we have, so we're going to solve 2x squared minus 7x plus 3 equals 0. Now notice that 0 is over there. We have to have that again with that quadratic formula. 0 must be there. If it's not, we need to work to get 0 on that side by subtracting whatever's there or adding whatever's there. All right, so this actually is factorable, but it's a little bit trickier than some of the ones that we've seen. So I'm going to do this using the quadratic formula. Your a here is 2, your b is the negative 7, and your c is the 3. And then from here, it's literally just plug in and simplify. The simplifying can get a little messy, but it's straightforward is how you do this. So negative b, that would be the negative of negative 7, plus or minus the square root of b squared, which would be negative 7 squared, minus 4 times a, which is 2, times c, which is 3, all divided by 2 times a, which in this case again is 2. All right, and then we just simplify. So this is the negative of a negative 7 is positive 7 plus or minus negative 7 squared. Be careful. This is different than seeing, this is just a side note, if you see negative 7 squared, that means the negative of 7 squared, which would be negative 49. But we're not doing that. We're doing negative 7 squared, which means negative 7 times negative 7, which is 49. All right, and then we've got 4 times 2 times 3 is going to be 8 times 3 is 24. All right, and that is a minus. Watch your signs in this spot. If you had 3 negatives, for example, it would be a negative times a negative times a negative. If you had 1 negative, just be careful with the signs. And then here, 2 times 2 is 4. All right, and then continuing to simplify. 7 plus or minus. 49 minus 24 is 25. And then over 4, and then square root of 25. This one's pretty straightforward. We get 7 plus or minus 5 over 4. All right, well, what do we do with that? This is kind of like square root property. When you get 2 answers, and that plus or minus, you can break it up and say, all right, it's either 7 plus 5 divided by 4, or 7 minus 5 divided by 4, and then simplify each one of those. This would be 12 divided by 4, which is 3. This would be 2 divided by 4, which can be reduced to 1/2. And those are your 2 solutions to that problem. So this was nice because you actually got, nice rational numbers. It is possible to get some where you don't have rational numbers and you want to write an exact answer. So if you see something that says write an exact answer, this is what it's referring to. So we're going to solve, x squared minus 3x minus 7 equals 0. Our a in this case is 1, b is negative 3, c is negative 7. Just taking our coefficients. And then just plugging in to solve for x. Negative b is going to be the negative of negative 3, plus or minus the square root of negative b squared, minus 4 times a is 1 times c is negative 7, over 2 times a, which is 1. And then we're going to simplify this. So negative of a negative 3 is 3, plus or minus the square root of negative 3 squared is 9. Negative 4 times 1 times negative 7. Notice there's 2 negatives here, so this is actually going to be a plus 28. And down here, 2 times 1 is just 2. And then this simplifies to 3 plus or minus the square root of 37 over 2. Now, square root of 37, I don't know, square root of 36 is 6, so I know it's close to 6. But this, we're not going to worry about writing a decimal answer here. This is considered an exact answer. So this would actually, your two solutions are 3 plus the square root of 37 over 2, or 3 minus the square root of 37 over 2. We could write that again as a decimal, but it wouldn't be exact. We'd have to round because that is an irrational number. It goes on forever and ever and ever. So we have to round. So this is considered exact. When we see that, we know that that is the exact answer to that. So if you see that question, write the exact answer. That's what it's referring to. All right, so that's solving quadratic equations in 20 minutes.